I've got some examples up here: a mother, a father, a child, and a dog, and they all have headaches. Even the dog has a headache. So we decided to give some Tylenol to each of them. And I want to know which one got the biggest dose.
The dog.
The dog only got 50 milligrams, right?
I also think it's the dog.
It is the dog. You're right. If we factor in dosage per mass, or in this case, weight, we see that the dog got 10 milligrams per pound. We probably killed the dog. That's probably too much. And we call that a lethal dose, LD, lethal dose. Lethal means that it was killed. The mother had the smallest dose. Dose is how much we're giving. And typically this is going to be on a logarithmic scale. Not always. So it's important that you check if they throw a graph at you. And the second part of the name, response, is how do the population or the subject respond to it? Well, that's simple enough. We give you a dose. What happens? That's what this graph shows us. So I'm going to start on the left-hand side, the one that says ED. And ED stands for effective dose. Effective. So if you have a headache, that is the dosage that makes the headache go away. Okay? Now, they marked 50 for all of these, right? On the response axis, we're looking for when do 50%, half the population, reach the response you're looking for. So at dosage, probably about 25 milligrams per kilogram, half of the people with headaches report that their headache is gone at that dosage. Okay. Now you can see some people reported much earlier that the medicine worked, their headache was gone. Maybe they're smaller, maybe they're more sensitive. Some people, it took a lot more medicine before they eventually said, yes, my headache's gone. Maybe they have a tolerance that has built up over time. Okay, so that's why it's a curve. Not everybody reports their headache going away at the same time. Now, notice there is an overlap between ED and TD. TD stands for toxic dose. And toxic means I feel sick. So you can have somebody who takes medicine and says, yes, my headache went away, but now I have a stomach ache. It's a side effect, right? So side effects start to get reported at dosage 10. And by the time you get to 120 milligrams per kilogram, 50% of your population is reporting side effects. All of them say their headache's gone, but they're all suffering from something else now. And then we finally get to our third line. LD stands for lethal dose. And lethal means dead. So if you give somebody 1,600 milligrams per kilogram, then half of your population dies from it. So how do we apply this to environmental science? Lead or mercury getting into water. At what point do half the fish die? That's LD50. We could use it for a pesticide. At what point do we spray this on corn and half the bugs die without killing the corn? So we could have two lines. Or we could test two pesticides against each other. Which pesticide kills the most bugs at the lowest dosage? And we see this graph has 4 lines on it, and that's because they are testing 4 different pesticides, A, B, C, and D. And mortality on the left, the things that are dying. United States EPA has determined all 4 could have negative health consequences to humans if applied at high concentrations. The dose is the poison. They have set a maximum application for the corn at 500. So anything above this level on this side is bad for humans. Okay? Which pesticide is the most effective at that concentration? So at 500, Where do the most pests die? Which pesticide? Well, the answer is D. It's the highest. It kills 100% at the lowest dosage. This question I love. This is just factor labeling, okay? LD50 for arsenic in humans is 13 milligrams per kilogram. Which of the following approaches should be used to calculate the number of grams of arsenic it would take to blah, blah, blah. I don't even care about the rest. What I'm trying to figure out quickly, because it's multiple choice, what am I trying to solve for? Number of grams. That's the only thing I don't know. Number of grams of arsenic. So I want to go through the problems and see which one gives me grams. Look at choice D. It doesn't even have grams. It's not that one. Look at choice C. It doesn't have grams. I don't want that one. Okay, those two are gone. I've now narrowed it down to 2. Here we see, oh, I've got grams at the end. That's what I'm looking for. But choice B has that as well. So look what cancels. Does pounds cancel here? No. Does it cancel anywhere else? No. So if it doesn't cancel, that ruins my problem. I need everything to cancel except for grams, the one I'm trying to solve. So choice B, pounds cancels, kilograms cancels, milligrams cancels, and all that's left is grams. I didn't have to look at any numbers. Who cares? All I'm doing is canceling units. Choice B was the correct answer. Delaney clause says that if you know something is toxic, then you can't put it in our food. Pretty simple law.